about data analytics and the general analysis of data in modern business. This includes a variety of subtopics, like the types of data analysis, and then some of those, or one of those, includes data mining, and then data mining involves a few more subtopics, and the one I want to focus on there is cognitive computing. So, starting off with overall data analysis, several different types of data analysis. And in data analytics, you can talk about business intelligence, statistical applications, predictive analysis, text analytics, data mining, as you can see right there. To specify further, there in business intelligence, that relies heavily on aggregation and focuses on business. Business intelligence in data analytics involves a lot of summary, a lot of taking a very, very large amount of data, think of big data, and averaging it all together. That's what aggregation is. And you focus on business information, obviously, because that's all you need when it comes to business intelligence. In statistical applications, this is mostly descriptive. It's less analytics and more just an accumulation of data, describing a situation, describing a demographic, describing a sales patterns, stuff like that. And it can be broken down into exploratory data or confirmatory data. And exploratory is kind of like when you don't know what you're looking for, but you just go out and search and you see what you can find. While confirmatory is more of you come up with a hypothesis and then you go through the data to see if you can find whether your hypothesis is true or false. Predictive analytics, that's pretty self-explanatory. It comes up with statistical models and predictive forecasting, classification. All that basically means you use the data to help yourself predict the future, to see, you collect all the data from the past and you analyze it in a way that will help you better understand what is more likely to happen in the future. Text analytics can be described as statistical, linguistic, and structural. And what that means is, imagine one example is you can do research on words that Facebook users use, or words that are tweeted very often. Even something like a simple, very modern version of text analytics is hashtags. When something is hashtagged, it's very easy to be part of text analytics because you can see live time how many people are talking about that topic. And that's like a very basic form of text analytics. And it extracts and classifies into forms of, extracts and classifies info from textual sources. So kind of like what I just said, taking words, breaking them down, looking for patterns. And then there's data mining. And data mining is when you're searching through data to locate patterns. It is based on modeling and knowledge discovery. And what that means is when you go through the data, you're not just searching randomly. You're looking for certain patterns, certain knowledge that you can discover from these patterns, and you do that by making models. It's predictive, not descriptive. So when we talked about descriptive analytics or statistical analytics, which are descriptive, that's not what this is. It's much more predictive. So when you go mining through data, you're not just looking for mass amounts of information. You are looking for information that will help you predict. It's a little bit part of predictive analytics. And then you're trying to extract patterns, not data. So data mining can be a misnomer. You're not mining the data. You're not mining for data. You are mining through the data. You're not digging for numbers. You are digging through the numbers, trying to find patterns. And it's used for cognitive computing, which is what we will get to soon. So with modeling, you construct algorithms and models using big data and large databases. It's pretty self-explanatory. You come up with mathematical equations and stuff like that to help you sort through large amounts of data. Knowledge discovery, again, self-explanatory. You use the information to help you learn new things, and you use the analytics to discover and improve. And again, that goes with predictive, which is what is next. Again, using the data to predict the future, it leads to improvements. The main point of predictive analytics is, again, it's not just silly looking through numbers. It's very purposeful, trying to help improve in the future. And there's pattern extraction. Again, not mining through the data. It is mining through the data, not for the data. And patterns help answer questions, which is kind of like when I was talking about when you come up with a hypothesis and then you see if it's true or false. And then lastly, cognitive computing. It is a simulation of human thought called artificial intelligence sometimes, and it's a computerized model. So when I was talking about models just a few seconds ago, it is a huge, huge computerized model, really several models combined to make one big artificially intelligent system. And by artificial intelligence, again, we mean the simulation of human thought, which is where we see Watson. So artificial intelligence, you think of data mining, pattern recognition, language processing, machine learning algorithms, all of this combined to make systems like Watson more like humans. So quickly, Watson, it's a big supercomputer, artificially intelligent. It's won Jeopardy. It's beaten chess masters. It's very, it's got a lot of good credentials so far, and it's still growing. And it's used to make, right now, its first commercial usage was to make utilization management decisions in lung cancer treatment. So it is being put to good use. So data analytics overall, you can see that the development of Watson and data analytics and data mining and cognitive computing, it's all combined, and it shows how computers and data analytics are improving the world today.